and we're good to go. Sweet. So last time we definitely got the stairs. Let's go ahead and show everything I got, just because I will need my my abstractions from last time, so my model as well as my stair. And yeah, mine aren't very interesting today, but they are kind of my tutorial stairs and things like that. So let's get to it. First things first, we're talking about actually the site. So let's get a couple of things, because it does say in the model that eventually I'll be making a topo model of at least 10 to 20 layers, and it definitely needs to be a 6x6 square at 1/8 scale equals a foot. So as you can imagine, it also says I need to put my name on the bottom. That's also very important. As you can imagine, it's going to be pretty much about the same size. In fact, you may see some of the complete models even on your computer. That's a good go-to, right? Definitely a great example of the exact same assignment, right? So let's do a few things. We can get topography in a lot of different places. However, the assignment's pretty specific. It says I do need to pick somewhere in San Antonio. So, well, I'm going to go to Google Earth. And for my example, I'm going to go to San Pedro Park. But for your exercise, you're more than welcome to pick anywhere in San Antonio. And the reason I say anywhere in San Antonio is because we also have the San Antonio hydrology map. Which is really nice because, well, we usually kind of fake it sometimes, or even just kind of look at the land and kind of model it ourselves, especially in studio because it's not a real life situation. But I definitely want to make some good practice, and as you can see, Bexar County has been entirely studied for its waterways and even its topography. So I'm going to go all the way to San Pedro Park, which is this wonderful green square. And it has all the topography lines. That's of course what these are. And if I zoom in, it really has all the topography lines. So if you have a project in San Antonio, there should be absolutely no excuse that you can't find the topography lines now with this wonderful resource that comes from the GIS system of San Antonio. And I'll go ahead and actually put that before I forget here, just in case you need it. So first things first, we need to select an area that has some verticality to it. Now, yes, I guess I could pick technically the tennis courts. Really for the sake of the project, I could either treat this with utmost seriousness for my portfolio, or in my case, it is for a tutorial and I am just explaining the technicalities of this program. So let's, I don't know, that looks pretty interesting, but a lot to trace. But I know that particular area, and yeah, it is vertically interesting. It goes from flat to a lot of slope and back to generally flat again. And of course we have San Antonio College even, right? And that wonderful filled parking lot. Anyway, that's looking pretty good. I'm gonna just get a portion of it and enough information, so I definitely want to get the street view, because I'm gonna have to line these up with something, right? Either that or sort of fake it. And to be honest, for this assignment, I suppose I could, but let's get something in there. Got a piece of it. Let's go to Google Earth and get relatively that same area or that same piece. No, we don't need the Villa Savoy. Let's go to San Antonio, San Pedro Park. So of course this is the first way that we would make our topography in Rhino. So this first way is, of course, we have to gather some information so that we can trace it and turn it into a digital model. So in my case, I'm going to go around to that same area. And really I don't need this Google image unless I was truly making it to scale. So I do want to show you how to do that as well. And that way you know how to overlay images and trace them in Rhino, just like we could in Photoshop or Illustrator. So, give or take, that's about the same thing. Like I said, I just need enough to overlap them and make a scale out of them. Another great thing before I took that screenshot would to be actually get a measurement, right? So of course, I believe in Google Earth we can still measure with this little measuring tool. I just need something, right? That way I can reference it. So I'm going to go with 10 feet. Like I said, it doesn't have to be perfect. It just needs to be a known measurement. I could choose 43. Again, it's just important that I remember that number. So I'm going to go ahead and click done and keep track of that 10 feet. Oh, apparently I got to save it. 10 feet. I don't know. That's kind of hard to look at, so let's go with something a little easier to look at. 30 feet. Saved project, I guess. Okay. Can I exit this? Gosh. Okay, there it is. So we have it. Still there. It's changed up a little bit. It used to just kind of draw it and stay there no matter what. But anyway, now we'll get our screenshot. That way we can, of course, overlap those together and see how they relate. Right? Because obviously this looks like a flat image. It doesn't look like a hill yet. Another thing that we can do, right, just in case you need this for studio, I won't actually go through this process, but there's also STL, so STL2 as in the number 2, terrain. So if you just look at that, so terrain to STL, sorry, I had dyslexia. Well, what's really interesting is you can also create a digital model from anywhere on Earth based on the LSAT data. So yeah, it's also named the same as a test. But anyway, what's kind of interesting is I don't find it to be as accurate and quick, unfortunately. What's interesting is you can produce a 3D model that you can open in Rhino using this website as well. So I'll go ahead and put that one, just kind of for resource also. Oh, that one gets a cool little bubble. Sweet. Anyway, so let's continue. We do have our images. And I'm going to go ahead and push this all to the side. Otherwise my computer's going to freak out. I'm just going to go ahead and hide that all. I almost treat it like it was a new project. Maybe I should move it out of the way first so I don't overlap. Get a good distance out there. Of course, you can see how slow it's making my computer. So I'm going to hide it and remove our speed a lot better. So first things first, I'm going to get those pictures. And just type in picture. If you have an older version, it's picture free. And let's get those screenshots. So that one, and I guess I gotta do one at a time, that's alright. Pick and choose. I'm gonna hit spacebar. It's gonna enact the same thing again. Fake it till I make it, and we're good to go. Next thing, I can click on the image. I can go to its properties. I can go to this little toolbar. I forget what it's called. I think it's just materials. Doesn't want to highlight. That's alright. Yeah, it's the material property. Looks like a little paint tube. Well, what I like about it is, of course, I can control the transparency of an object. That way I can mix and match and scale them to make them align with each other. Now, again, this isn't super important for this project because, well, I can trace it and just move it to 6x6, right? For this project, it doesn't really need to be to scale, honestly, that true 48 by 48 feet. However, I do want to show you how you would do it in Studio. So let's align those up. If it'll think about it first. Should probably close Miro, to be honest. That takes up a lot of... Let's close that one out. We got enough links for today. Let's close some of these. Google Earth will take up a lot of your processing speed as well. And probably hydrology and contours is taking up a lot of space as well. In fact, just get rid of the browser. And of course on a Mac, just because you close it doesn't mean it's actually closed. So hopefully get my computer running a little bit quicker. At least for this process. Sweet. Alright, so let's line these up. Now, I guess the first thing we could do is actually scale this first image. That way we don't have to scale two things, right? We're just scaling it to one. So first things first, I'm going to draw a line. And I think I did 30 feet. Was that right? I think I decided 10 at first, but then I think 30 feet would have been easier. So there's actually 30 feet according to Rhino, right? That little green line that hopefully you guys can see on the projector. Yep. For some reason it's like looks black over here. Anyway. So first things first, I want to align that. So I'm going to move my image exactly to this line. Now, don't get me wrong, that looks a little weird. I'm going to just fake it till I make it and choose that midpoint of it and line it up with that line that I drew. So in my case, right to that end point. And I basically just need to scale the image, so I'm going to type in scale. It's going to ask me for a base point. I'm going to click that same base point. It's going to ask me, okay, well, where's the other part of this line that you want to make a certain scale? I'm going to be like, well, it's the other end of this yellow line. I'm going to click, and then it's going to be like, okay, well, what new place do you want that to equal? I'm going to be like, well, I want 30 feet to equal 30 feet, so I'm going to lock it into the other side of that line. Bam! Instantly, this image is now to scale. I don't know if I've actually shown you guys this particularly yet, but this is probably the easiest and most used method of scaling, right? What's nice is, like I've mentioned before in my previous tutorials, everything in the digital realm should be 1-to-1 scale. 30 feet should equal 30 feet. You should never draw, like, say, 1/4 scale in the digital space, right? That doesn't make any sense. What if my studio professor wants 1/8? Am I going to have to reduce it 50%? Yeah, rather than just print it at 50%. Anyway, maybe a different discussion, but that's definitely the best way to scale something. Now, we just have to align this up with it, and not exactly a big deal. Like we've done before, and right now it definitely seems like it's at the bottom because we can't see it. So I'm going to go ahead and move it to a top layer. This layer happens to be on top. Yeah, I should be more organized. However, I'm just going to change that layer so of course that we see it on top. As you can see, it's way smaller. So I'm going to go ahead and lock this into place so I don't do anything to it. That, and so I don't accidentally move it. However, since I'm recording screen, it is kind of going in and out, so I do apologize. Hopefully the record screen actually, it's funny, sometimes I even see something different than it actually records. So I don't know, maybe it actually looks fine and looks really weird that I'm talking about nothing in the recording. Anyway, so let's go ahead and scale this proportionally. Gotta hold shift to do that, right? And lock it in as close as possible. I'm just gonna fake it till I make it. I'm gonna call that the street. Obviously I went way too big. Scale that down just a little bit. As you can see, I'm just aligning it to the streets first. And not too bad. Now we can definitely assume, at least in this case, that our image is the same as that Google image. So to save on some CPU usage, I'm going to go ahead and get rid of most of this imagery. Now it says I need a 48 by 48, so I'm going to go ahead and make a rectangle that is 48 feet, enter, by 48 feet, enter. I don't need a lot of this, right? So maybe I just need this small portion. I notice, yeah, there's a lot of lines going on there, but I do want some, you know, maybe a little bit of this flat part, a little bit of the other part going on. So I don't know, I kind of want some of that flat stuff up there and a little bit of flat stuff down there. I'm not really worried about that tree, so I'm going to go ahead and hit trim and get rid of everything I don't need. So pretty much all of it. And I'm left with this nice little model that resembles maybe where I'm going with this, right? Obviously it's a 6 by 6 inch model at 1/8 scale. Now it's not really to any scale, right? Because of course it's at 1-to-1 in a digital realm. So yeah, not too bad. Let's get rid of some things. I don't need that, obviously, to trace it. I just really needed that Google image for scaling purposes, right? And honestly, for the sake of computer graphics, and some of you that may be in D1 or D2, you know, I'm thinking of Mark, who's not here today, This is where I'd say kind of mark, just give us a 48 by 48 square. Some of you guys that are, of course, in D3 or D4, let's be a little bit more accurate about this. Of course, let's treat this more like a studious project and have a very true 48 by 48 feet. Anyway, so we have our piece. Next thing we need to do is maybe honestly keep to at least my rules, of course, being organized. So I'm going to make a topo layer, and yeah, most of the time topo layers are green. I'm going to go with, I guess, green, dark green. Let's change it up. I don't know. I just want to do something that I know will you'll be able to see it. So maybe one line time I haven't really showed you guys yet is the control point curve. Probably one of my favorites, right? And essentially we need to draw outside to the outside of this because, again, I can always trim it and the curve does a little bit of funky things. So I'm going to fake it till I make it, and I'm just going to trace this. Get some of my topography lines. And like I said, I kind of want to get outside of the box. That way I can just trim these all at once very easily. Now I'm going to start on this side. I'm going to fake it till I make it because, well, look at that thing, man. It is pixelated. So there's no way that I'm going to get it absolutely perfect. So that's okay. If you go outside in the real dirt, it's not very perfect either. In fact, if the wind blows by, it's going to change even arguably a little bit too. So one could argue that you're never going to get an exact representation of a digital model in of the physical realm. So there is that argument too. But for the sake of tutorial, I'm going to go as fast as I can and kind of just fake it. As you can see, I'm kind of going for the best, right, interpretation of whatever I'm looking at there. I know enough about topography that it kind of follows itself, right? So I'm kind of just making the next line and of course following the previous line. Sorry if that's pretty hard to see in the projector. However, should be able to see it a lot better in the recording. Speed is the name of the game though, for sure. I'm even skipping some of the lines just for the sake of speed. Let's skip that one too. But as you can see, the curve line tool is really useful just because it kind of bends for you, right? Sort of making up for kind of all that pixelation that we have. Of course, I can add more points. I can get really fancy with the spices and kind of make it, you know, resemble dirt or topography, you know, very easily. But sweet, got something there. I'm going to go ahead and hide this image so you can kind of see what we're left with. Very about the same, right? Now I'm not going to trim it yet, just because I do want to show you a couple things that we can do to achieve this surface, right? So first things first, well, it's flat, right? And we obviously know that these lines represent slope. So, well, in this case, I'm going to use multiple views and just move those up manually, right? So what do I know about topography lines is that, well, each line represents usually a foot of elevation change. So I'm just going to go ahead and move it, right? So move. I'm going to go ahead and stay in orthographic view, just because I do need it to move straight up and I don't want to hold shift the whole time. So I'm going to type in 12, enter, and move it. Next line, move. I could also just type in spacebar because I'm basically enacting the same move command over and over again. This one has to go up 24 inches. Or I could type in 2 feet. What about the next one, guys? Spacebar, click, 3 feet, enter, click. And you start to get really good at this. Right? Start playing it like a piano, go 4 feet. Right, and we start to get this slope out of it. Now I'm going to realign it so we can see that a little bit better. But it almost starts to look like a wireframe, right, if you will, right, of that and what is starting to happen. Like I said, this part 1 is really just about the topography. So next time on Tuesday, I'll definitely be going over putting this all together, right? And then of course also even Thursday before spring break, I'll have one last tutorial. Again, I want to get all three of these out. That way you can of course digest them and practice over spring break if time allows it. So next line. Unfortunately, we do have to do this kind of manually. I don't really have a way of kind of spreading them out all perfectly yet. I heard that you can use array, so I'll throw that out there just in case you kind of want to test it yourself. But honestly, I'd rather just spend 5 minutes doing this manually than spending 5 hours trying to figure out some sort of better automated way, right? So there is a time and a place for things. We'll throw that out there too. So let's take that. Sorry, next line, move, space, I think it was 5 feet. Awesome. Next line, 6 feet, 6 feet, enter, 7 feet. So we got quite a hill here. 8 feet. I know, the suspense is building. You just can't wait to see what this hill becomes. 9 feet. So obviously this is why we're only doing maximum of 10 layers. Can you imagine what I did to these guys? Right, they had to make 40 layers, poor things. However, I did give them a lot more advanced options that I found out in time were way too advanced for a beginning class of computer graphics. So I had to learn the hard way, but that's alright. There's nothing wrong with starting simple. But nicely enough, we do have 10 layers. So this would be perfect, you know, for our model. Right? Definitely looks like it's coming up. And in fact, I might need a last line to actually indicate and tell the program that we're up in the sky. So I'm going to take the intersection point of that, or the apparent intersection. It's not really intersecting. It is in this view though. And I kind of just want to get the last of that. And I'll show you why later. Let's take that curve. Oh, that's kind of funny. It kind of takes that point. However, I do need it to be flat, so I can take that point. And this is where near actually does come in handy. So I'm going to go ahead and move that particular point and get it perpendicular or near. Right? Turns out perpendicular was just fine, but very easy in making that flat. I could have used Make 2D as well, but I need to move this, and I'll show you why. 10 feet, right? Because we kind of have to complete the rest of the surface. Unfortunately, the program has no idea, you know, what we're doing. We're just using it for the tools of visualization that it does have, right? So, a couple of ways that we can make this surface, right? And the reason also I didn't trim it yet, right, is because, well, I can take all these pieces, except for that bottom piece. We don't need the bottom rectangle for this. And we can loft these together, right? So if I take that last piece too, and as long as they're not touching, I don't know, let's see what that one does. Let's loft them, right? So L-O-F-T, loft. Right, and as you can see, it starts to mingle these together, right, into one conglomerate surface that, yeah, don't get me wrong, on the edges doesn't quite look like dirt, but in the middle, you know, sorry, I guess I should have gone to rendered view, because it definitely looks dirt-like, right? And there's actually a couple things we can do to this. So, of course, loosen it or tighten it. I typically prefer loose, right? If you close the loft, it's definitely going to make like a tube, and we definitely don't want a tube, so don't close the loft. We could even rebuild it, right? He's like the $6 million man. We can rebuild him. We can crash our computers instantly by using 100 points instead of 10. Okay, I'll close the loft real quick to kind of show you what 100 points does. But essentially we can loft a surface. Now to show you what that looks like in rendered view, it looks like a white blob, probably because I got a lot of sunlight going on. And I don't want to crash my computer, so I'm going to go back to shaded real quick. But as you can see, it definitely makes a three-dimensional surface, right? So let me go ahead and make a copy of this, because I do want to show you a couple ways that we can make this thing. So the first way is, of course, lofting it and trimming the heck out of it. So, we need wire cut, and it looks like we still need a couple of pieces, actually, of the rest, right? So I'm going to save that copy, redo copy, keep that one. So that's why I drew the rest of it. That way I could basically resolve my surface, right? So obviously you can see how it worked here because I drew that extra polyline. And you can see how it sort of left a hole because, well, I didn't draw that extra polyline. So let's draw that extra polyline, at least on this bottom piece. That one should be fairly easy because it's already on the ground and flat. So, okay, here's where near will come in handy. Endpoint, and I'm going to just choose near again just because I need it to be somewhere on that line. So yeah, I guess near isn't entirely useless, right? But what's nice is, well, let's try the loft again with our new curve. And again, this is before I'm trimming really the surface. Let's try loft again. Right, so now it definitely completes it, right? Arguably kind of stifles it a bit, kind of weirdly, but not a big deal. For the sake of accuracy, I'd probably be indifferent about it, but not too bad. That's looking pretty good. We'll do 100. 100's pretty safe. There's enough lines in there to kind of get it. I mean, this is a great way to make curtains too, if you're being completely honest. But I use it to do a lot of three-dimensional surfacing. In fact, sometimes I'll draw the profile of my head and the front of my head, and you can, of course, loft those curves together to make a human skull or any kind of surface. Now, don't get me wrong, we just needed it for topography today, but actually the way I learned to do this was modeling Sonic, to be completely honest. Right? Like I was mentioning in high school, one of the first things I did in terms of computer was modeling an entire scene of Shrek. Right? So don't get me wrong, some of this stuff is the exact same tools, but of course being applied to architecture. But that's looking pretty good. We definitely have a solid surface now that we can cut from. However, we know that wire cut only works with a solid poly surface. So I'm going to go ahead and make a copy just in case I need this again, or just in case I mess up. Good habit to have. And let's go ahead and offset surface because I want to give it some thickness. In my case, you'll see that I both have things going up and down. That's not a really good sign, but let's see what happens. Because that would mean my normal is going one way and my normal for another is going the other way. That's the perpendicular plane or tangent to any surface, which is what it's trying to show us or indicate. So let's hit enter, see what happens. Probably going to be something funky, especially right here. Oh my lord. So obviously you should choose the distance before you hit enter. But as you can see, something is clearly wrong, right? Definitely doesn't look like anything, but I kid you not, I had this one master class where we were told to do stuff like this on purpose, and it was called the method of the glitch. We were supposed to make stuff that we didn't intend to make. So anyway, just kind of throwing it out there. This is a pretty cool object, to say the least, but not why we're here. So I'll tell you the reason why that happened, and it was because of those little arrows, actually, that revealed themselves. This object and its curves might need to be flipped. So for instance, the direction that I drew this, right, you may have noticed I started over here and I drew it this way. However, did you guys notice when I drew my lines, sometimes I drew it this way first, sometimes I drew it that way first, and you may think to yourself, well, of course, Professor, that doesn't have any impact on my drawing, right? Incorrect. And in fact, I did it both ways to kind of show this as well. Like I said, I often like to bake in the mistakes in there on purpose to show you that, well, you might realize that you need to flip F-L-I-P, yep, flip. Literally you'll hit it, nothing will happen, or visually nothing will happen, but the normal of the line has been flipped, right? Now, unfortunately, there's no way to really tell until, again, at least not to my knowledge, no way to tell yet. I've heard that you can actually have it change colors when it is like a certain quadrant flip versus another. But let's try this again now. So I'm going to loft these again. Oh, maybe I didn't get the right lines. But you may notice, at least in this method, you do have to loft some lines, or flip some lines. What I would say is if you draw them all in the same direction, so from what quadrant to the direction, in my case I chose like a southwest direction, I chose a northeast direction, so on and so forth. So clearly I might have to go in there and rearrange my lines. So let's try that loft again. In my case, these lines. Sweet. You'll notice that some things will start to resolve differently. Right? So let's try that again. Offset surface. I can also click on these particular lines, right, to flip them. However, it looks like my surface is pretty bad. So I might need to actually chop it up a little bit first, because it doesn't look like flipping changed anything. So that's okay. Like I said, there's about 15 other ways to do something in Revit, or sorry, in Rhino. Also could be said true for Revit. However, what I would do is, of course, loft these again. So loft, or sorry, get rid of that one. We don't need that bottom one. And let's try and trim it first. Fake it till we make it. So I might have to mess with the accuracy a little bit. Make it a little bit bigger. That way it reaches outside the extents. I'm gonna need this little guy right here, and I'm gonna hit trim. T-R-I-M. Let me see if I can trim that surface. Yes, a nice clean edge. So what's nice is I made the surface a little bit bigger so I could trim the edge. Now let's face it, no studio professor is ever gonna notice, anyone ever is gonna be like, did you make this slightly 3 millimeters bigger than it should be? Right? So again, keep in mind that I did just ruin the accuracy. However, at least in this case, specifically with topography, I don't think I would even notice. So, but that's looking pretty clean. Let's try that that offset surface again. See if we get those flip errors. So offset surface, and would you look at that? No more ruined arrows. So I don't want it to go up. In fact, I want it to go down into the ground. I don't want to kind of ruin the topography on the top that I have going on. And I do want to rechange its distance to, say, something simple like, I don't know, 6, or I don't know. I do want a significant base, and I can always chop this thing up. So let's go 12 feet. You know, I am already going at 10 feet, so I do want to make sure I get it all. So I'm going to go ahead and type 12 feet. Enter. Think about it. There we go. And as you can see, much better than that weird chaos glitch that we got, right? But as you can see, it's still kind of funky, so we do want to chop it up a little bit more, right? But what's nice is now we have this three-dimensional model for our topography surface, right? But now we have a box that we can, of course, wire cut. Now I can't see it too well because I got some stuff in the way. Let's move that out of the way. And chop this guy right up. So in my case, I just need a line. I'm going to go with 0. Wire cut this piece. Make sure that it goes all the way through. So yeah, definitely can run into a lot of problems when we're making three-dimensional surfaces, especially from scratch, right? But as you can see, we can start to dissect this model. Obviously, I can chop it off here, so I can use my square. Wire cut. Now, as we know about wire cut, let's see if this actually works, because my line is unfortunately right on it. But yeah, basically using, you know, that initial square that I drew, basically chopping off this little extra. thinking about it, it might fail because, again, you can't usually have the line on the object. So I'm going to cancel it if I can. Please don't freeze. Don't do it. Don't go towards the light. Yeah, go into wireframe mode. Good job. So yeah, as we know, wireframe does usually have a hard time. Oh, it looks like it made something altogether. There we go. So you got to get that curve, you got to move it just a little bit outside of the object. Not a big deal. Wire cut again. And let's go straight through. Nice. So yeah, it's going to get rid of that little edge that we didn't need. And for the most part, you know, you definitely have a good sign because, well, it's starting to look like that final model, right? Definitely has a 6x6 dimensions and definitely has a slope, and we definitely have a certain sense of accuracy to it. So that's looking pretty good. Lastly, you know, we want to make this into a digital model, but I also want to show you that there's another way, just in case you can't get to this method, right? Just in case Loft isn't working for you. Maybe your geometry is too messed up. Maybe you got certain things that just aren't lofting, right? For instance, like closed curves versus open curves. Who knows, right? So another option that you have is, of course, still tracing it and still making kind of the rest of it. However, let's also get a copy of this, just in case I messed that up. Let's go ahead and make 2D this one. I want to go ahead and flatten it. I don't know why there's not just like a flatten command, but because that would be pretty useful too. But I can actually make these layer by layer, and this method actually might be faster for the laser cutter. So don't get me wrong, this one's going to be great for our perspective views and anything three-dimensional that we need, right? You know, because now I don't need a surface. I can literally render out a surface. I can literally put grass and stuff on this in Photoshop and all kinds of things. However, it doesn't really help me for producing a laser cut model. However, it's a good model for, say, the 3D printer. So don't get me wrong. What I'm saying is that you might find that you need both methods, right? Obviously, this next one is a little easier for the laser cutter. I just really need two-dimensional information for the laser cutter to actually be effective. So in my case, I just need these parts. So I'm going to trim everything I don't need. So obviously, I don't need the laser cutter to go outside of the boundary. It's just going to waste time and honestly burn the equipment. So in my case, I know that I have 10 layers, so I can copy this 10 times. 1, 2, 3, 4, 5. In fact, I'm so smart. I know that 5 times 2 is 10. So, and really, I just have to build the layers here. So again, this is kind of helpful for the laser cutting method, right? Now, the first one I need to be actually a rectangle, right? Because I do need a base to put this all on. So I'm actually going to get rid of all my lines. There's my first piece, my first layer. So I stack the next piece. Of course, it's going to be this guy. So trim, and get rid of that one, and every line before it. There's my second piece, my third piece, right? So no longer need this one. I'm going to trim from this one. If that line is actually connected to the edge, it will trim. Might not actually be connected to the edge. That's all right. That's okay. There it is. It was getting that line that we drew. And there's my third piece. And as you can see, some of us might go, well, Barrett, why didn't you do that one first? That one's way easier, right? But again, it's because my point is you might very well need both, right? Obviously, you're going to need this one for the laser cutter, but you're going to need this one for the future. So it's worth your time to investigate, right? But as you can see, we can just continue and continue on this one. All right, we can go to the next layer, trim, bam, bam. And these would be literally the layers that I would send to the laser cutter. Now, for the sake of conversation, and since we only have about 7 minutes, let's say I completed all those, right? I would have my thing ready to go, and I want to send this to the laser cutter, and the laser cutter bed is a 1 by 2 feet bed, right? So let's just get that ratio first. So I'm going to do 12 inches by 24 inches. And that's actually the true size of the laser cutter, right? Remember, after all, we are at true scale. These are actually 48 by 48. They're actually huge, right? They're not actually 6 by 6 inch models. So we kind of have to scale this up or scale these down, right? Now, honestly, it doesn't really matter which one you choose as long as that rectangle is the correct ratio. Again, this is where, you know, especially me and Franco definitely differ. He likes to use the program for it. I like to confirm it manually, and of course keep everything at 1:1. So there is some different methodologies to it, but as you can see, we either have to shrink this down or make this larger, right? So what I suggest is, since this is the correct ratio, we just times it by the method of scale that we need. So in our case, we need 8 feet to fit in 1 inch. So what do? Times it by 8, essentially, right? So let's do that. What's 12 times 8? Anybody? 96, thank you. So I'm going to make a rectangle and say 96 feet. And what's 24 by times 8? 96 times 2? Is it 163? Yeah. $180, 186, right? Oh wait, 184. What am I talking about? Thank you. So now it's the correct ratio, and now my 1:1 pieces will be 1/8 size. Right? Does that make sense? All right. So of course, how many of these should I be able to fit on one piece, guys? If these are 6 by 6. So as you can imagine, this is kind of my laser bed. I should be able to fit. Oh, I did something wrong. Maybe a wrong calculation. Ah, there it is. So good. Always be sure to check yourself, right? In fact, what's funny is I could have just put 6 together knowing that as well. Right? So, you know, math is never a bad idea, but this is exactly what we would send to the laser cutter. You know, is this piece. Now, of course, mine's kind of all broken up. Those aren't actually squares. They're make 2D of, you know, a lot of different lines. So what I would want to do is, of course, join them, you know, to make them one line, you know, and things like that. So we can refine, we can clean, and keep in mind, some of this stuff starts to get pretty advanced in terms of what this means and translates to in terms of how the laser cutter is actually going to work and move and how quickly it'll go. Obviously, the more clean your lines are in your drawing, the faster your laser cut process is going to go. However, last thing, right? So we definitely know how to get this on a laser cutter, right? We definitely know how to get it at least on the board. But lastly, I do want to show you another way of modeling it, you know, just in case, again, that loft method just might not work for you. You might have a different situation. So I wanted to show you that you can also, of course, extrude these things, right? So I'm going to join them. And in fact, join works no matter what. As long as lines are touching, you can select everything and hit join. If it's not touching, it won't join. So it's going to join that for me, join that for me. And again, I'm working smarter rather than harder. Also, the same thing could be said about extrude curves. So an extrude curve. How big are they supposed to be? Well, 12 inches, enter. And I could build another model. So I'm going to go ahead and move that one. And this is very similar to, like, you know, if I had stacking cardboard, right? You can almost imagine that these are all pieces of digital cardboard. And I'm quite literally just stacking and gluing them. Probably should have made a copy just in case I mess up. But as you can see, there's another effective way. Something probably a little bit more familiar, like if you've been in D1 or D2, right? We stack that cardboard to show the topography. So don't get me wrong, both this method is absolutely fine and this method is absolutely fine, right? However, this, with a minute to spare, right? I did take a little long on my errors, but again, I know you guys are going to run into those same things, and let's face it, not all topography is the exact same. So you're more than welcome to, of course, get started. What I would say, especially for those of us who have already completed exercise 3 and exercise 4, find a spot in San Antonio. You know, look around, look at that topography map, find something, you know, generally interesting, give yourself a challenge. Like I said, I'm not really too worried about the scale. If you want it to be this, what I would say is just don't make it flat, or it's just like 3 layers. That's kind of boring. Try and find some good slope in there. If you find something that's kind of like you just can't find 48 by 48 feet, fake it a little bit. You can give us 100 feet by 100 feet. You know, we're not going to, again, pay attention to scale. What I do want this to be is honestly fun and an experience in learning the equipment. So if that's what it takes, that's what it takes. So any questions about the topography so far? I know kind of a short room, and usually this has a lot of questions. Like I said, eventually we'll do part 2 on Tuesday and part 3 on Thursday before spring break. Sound good, guys? Let's get out of here.